All right, scholars, thanks for checking in. Let's take a look at waste management. And hang in there, we're almost there. So we'll take a look at types of waste, landfills and incineration, and hazardous waste issues. And actually, we're going to finish up with some economics too. All right, there are three main categories of waste. We got municipal solid waste from homes, schools, small businesses. Industrial solid waste from production of consumer goods, mining, petroleum extraction, agriculture. Hazardous waste, which can be toxic, chemically reactive, flammable, or corrosive, like the things that you found in your home during your hazardous product survey. And just a reminder that wastewater is also a form of waste. Paper is the biggest component of municipal solid waste in the United States. Fortunately, we do a lot of recycling, but it still is a large component, even still. So what is a sanitary landfill? It's a landfill where we are burying our waste or piling it up. The sanitary part comes in because we're trying to do it in a way that doesn't contaminate the environment. So there's some basic features here we should talk about. So first, we have our most cherished aquifer to holding our groundwater. We want to make sure we keep that clean. So what we do at the bottom of our big hole where we're going to bury our waste is we line it with an impermeable layer of clay. Clay does not allow water to pass through it. And above the clay, we put a plastic liner, and that provides even more prevention of water contaminating our aquifer. Above the clay, we put some gravel, which allows water that might be in the solid waste to collect, and then we can pull off that water with pipes and analyze that water and especially treat it if it's seeming to contain some toxins. So above the water is where we have our solid waste, lots of it. And most of this decomposition occurs pretty slowly. We want to try to keep this waste as dry as possible so that we don't have too much water that's picking up pollutants. And when you have dry waste, it decomposes very slowly. And the decomposition that does happen is mostly anaerobic because it's buried, so there isn't much oxygen. Anaerobic decomposition produces methane. So the methane can be recovered from this pipe and sent to a methane gas recovery well. And from here, usually the methane is burned off before going into the atmosphere as a greenhouse gas. But we can also use that methane and burn it for fuel to make electricity. So that's an example of cogeneration. And then ultimately, what we hope to do is cover up our solid waste with soil. Actually, that is what we do. We actually each day they put a layer of waste and then they cover it with some soil, and then the next day put more waste, then cover it with soil. So you can see here how this structure is set up with the layers of solid waste separated by layers of soil. So some terms here you should know. Leachate is the name of the water that's picking up some chemicals as it drifts or as it filters through the waste. And even when you have a very well-lined landfill, there's always going to be some leachate that escapes. And I already mentioned about the dry conditions and the decomposition. So it's kind of a balance. You want it to be dry, but too dry and things decompose too slowly. And the other thing here is the concept of NIMBY, not in my backyard. Nobody really wants a landfill in their backyard, so it's hard to find locations. So another option besides burying it is to burn it, and that's incineration. This can reduce the volume by 90%. You still have 10% of it left behind as ash, and that ash you can put in a landfill. It's a pretty controlled burn, and the smokestacks have some filters on them, so it's better than just open air burning. But it can still create new chemical compounds and emit toxic chemicals from the stacks. So we can create pollutants or secondary pollutants from the energy of the burning. So you may, to get a sense for that, if you've ever smelled burning plastic, it smells terrible. Those fumes coming off are largely toxic. So we have that same effect happening in the smokestacks. And because of the pollution, people often oppose them. But they are used in a lot of places. So waste to energy, many incinerators now generate electricity from the waste combustion. And we can use that electricity to generate heat, to boil water, and that steam can turn into turbines, turning the generator. So the same theme that we visited last unit with energy. This is an efficient and effective process, but the income from the power is pretty low because we can't produce that much power. And the expense of setting it all up is pretty high, so it can take a few years to recoup your investment. Here's a diagram of this setup. We have the waste going into a pit. We have a crane picking up the waste, putting it into the boiler, into the furnace. The furnace is heating it up, and that's heating up water in the boiler. That heated water turns the turbine, turns the generator, and we see these fumes that are coming off in the furnace. They first go through a scrubber, a wet scrubber, which knocks out some of the pollutants, and then from here it goes into a baghouse particulate. The baghouse is where we can capture particulate matter, so we can capture the ash, and then that ash can go to a a landfill, and ultimately whatever has not been collected as ash goes to the stack to be given off as air emissions. What's better than disposing trash is not producing it in the first place. So we can do source reduction, and our personal choices can affect that. We can use fewer items, we can buy less packaged and longer lived goods, and we can reuse items. From a manufacturer's perspective, they can make goods that have less packaging, they can make goods that last a longer time, and they could also have more efficient production methods. We'll take a look at that a little further on. So what are the financial incentives of reducing pay? Well, lots of communities are starting a program now where you pay as you throw, and people who waste more pay more. So maybe you're charged a certain amount for having a full trash can at the bottom of your driveway, rather than just paying a set amount every month. And there's also bottle bills, laws that mandate that consumers get money back for returning bottles and cans to where they were purchased. And perhaps we'll have things like similar things for bags or whatnot in the future. Okay, let's take a look at hazardous waste. We all have many hazardous substances in our homes and everyday lives, and we took a survey in our own homes for this. And here we see a community collection center. We have a center like this at UCSB, which is open every Saturday and Sunday. Hazardous waste means waste that poses a potential danger to human health. And there's four criteria for this. You saw this on the handout for your home hazardous product survey, and it's also in your Princeton review. Ignitability, substances that can catch fire. Corrosivity, that can corrode metals. Reactivity, that behave in unstable ways and can create chemical reactions that are harmful. And toxicity, substances that are known to be harmful to human health. And there are many types of hazardous waste. These two are the worst because they persist for a long time without breaking down. And the first one is heavy metals, such as mercury, lead, chromium, arsenic, cadmium, tin, copper. These are from industry, mining, and consumer products. And the more we mine them, the more we use them in consumer products, the more prevalent they are in our environment. And they're potent neurotoxins, so we don't want to have these things in our environment. Organic compounds, such as synthetic pesticides, petroleum products, rubber, solvents, preservatives, these also can take a while to break down. And many of them can be endocrine disruptors and things like that. So sometimes people or businesses resort to illegal dumping to avoid having to pay disposal fees. Not a good thing. But we do have special ways of disposing of hazardous materials. And one is that we have specialized landfills that are designed just for this. So maybe it has better clay layers or double layers of plastic, things like this, to prevent the contamination of groundwater. We also have what are called surface impoundments and deep well injection. Let's take a look at these two. Here's a picture of surface impoundments. You're basically taking liquid hazardous waste, letting it sit in a pond that is lined with plastic and clay for a long time. enough time that the water can evaporate, leaving behind a residue of solid hazardous waste. It's only for temporary storage, and it's not ideal because the waste may overflow, it might blow out, it might vaporize as waste, or it might even leak. So not really ideal. Another thing that we can do is we can inject hazardous waste deep into the ground below the aquifers. So in this diagram here, you see that we have an unconfined aquifer. We have some impervious soil that doesn't allow water to go through. Underneath that, we have a confined aquifer, which might be under pressure. And under that, we have some more impervious soil. So if we go down deep enough, we can get into porous rock that we can drill out, and if we have a nice pocket there, we can inject our hazardous waste and hope that we don't have any seismic activity or anything like that that would cause it to leak into our groundwater. But it is a possibility, and if it does happen, it's very difficult to clean up that groundwater. Radioactive waste is a special type of hazardous waste that is especially dangerous. It can last for hundreds or thousands of years. A lot of it's produced by the military, also by the nuclear industry. Hospitals, they use radioactive materials as part of their treatment and diagnostic equipment. And it's extremely hard to find a place to dump it that's not opposed by local people. We've been trying to develop a site in Yucca Mountain, having deep tunnels, but as you can imagine, the state of Nevada and its citizens are not real happy about that. So there's a special program set up by the government called the Superfund. That's the sort of trade name for it. And the Superfund program is for treating hazardous waste sites. And Superfund sites are heavily polluted areas that are eligible for special government money to clean them up. This started in 1980 and is administered by the EPA, Environmental Protection Agency. There are about 800 sites throughout the U.S. The closest one to us is in Lompoc. It's a site of some chemical contamination from a company. And ultimately, the Superfund cleanup law or bill tries to charge the companies for cleanup through a polluter pays principle. Makes sense. You made the mess, you clean it up, you pay for it. But it does offer some money to assist with that process. And let's close with this discussion about economics market principles. With all these things that we're talking about, we get benefit from these consumer goods, and ultimately we have waste generated from them. And so it's always a matter of looking at the benefit of it and then the cost. So cost-benefit analysis is a term that refers to whether the costs outweigh the benefits. So is it worth the damage done to get what you get out of it? To give you an example, we love our iPhones. We get a lot of benefit from them. But what are the environmental costs to manufacturing them? If we add up all those costs, does it seem that the costs exceed the benefit that we experience? Or does it still seem like the benefit outweighs the cost and we should continue manufacturing them? There are lots of costs that are hard to figure out exactly. It can be hard to measure environmental costs. There's lots of indirect costs, social costs as well, from people, child labor, things like that in the manufacturing of these goods. But this is the ultimate goal, to be able to do an effective analysis. There's a term here called externalities, and this is the unwanted or unanticipated consequences of using a resource. It can be good or bad. For example, mining for the iPhone metals used in the phone causes acid mine drainage and habitat loss. That's a bad externality. But with improved iPhone communication, we can develop better technology that uses less harmful metals. So maybe we can use this iPhone for the good, with a good unanticipated consequence. Another term to know here is marginal cost, which is the additional cost of additional steps. So, for example, how much more pollution is generated when producing 1,100,000 iPhones compared to 1 million? How does this compare to the cost of producing the first 100,000? So with marginal, it means as we add on extra units, how much additional cost is added on. And this leads to the idea of mass production, that it's generally it gets more efficient the bigger your operation. And so, okay, we'll discuss a little bit of this in class, and thanks for tuning in.